How's it going, everybody? This is going to be a really long, unedited video, but it's for me in the future and for the, upcoming biology majors that want to get into biology. And so I'm going to teach you about the immune system. All right, so straight up, right? I'm already stuttering. We got, these steps from exposure to immunity. Now, what does this mean, bro? What does this mean, bro? This is the first slide on this Quizlet. So I'm gonna keep it real. This is gonna be really hard. It's gonna get really weird. I'm not that good of a teacher, but it's really good practice, right? All right. So with that said, and with my voice being almost out, I got a new haircut, and we're just gonna get straight into this, right? All right. So when you get exposed to a pathogen, that's first gonna lead to that pathogen colonizing. So it's gonna spread all over your arm and stuff. Then it's going to lead to an infection. Think about yourself getting clawed or something. And then there's going to be a disease. You're going to start choking up. And then you got an immune response. Hey, back off, bucko. And then we got recovery. Oh, hey, I'm all better now. And then we got immunity. We big and strong. So the next time that pathogen comes, we're just going to beat the mess out of it, bro. Easy peasy. Let's get into it, bro. All right, so what is the overall movement through the immune system, right? So how does a cell know that it's gonna find that cell? I mean, how does the cell know that the body's being under attack? Bro, this is confusing me, bro. All right, so whatever, bro. All right, so first we got a stem cell compartment. What's a stem cell compartment is gonna go into, oh crap. All right, so next up, we have a stem cell compartment. Think of this as your purse, right? We're going to have all of our little immune system cells. They're going to be in here. They're going to come out whenever they're needed, okay? And then we have our centroid lymphoid organs. And that's going to be the contents of whatever's inside our lymphoid, or what's inside our stem cell compartment. So we have this is our stem cell compartment. We open it. We have our central lymphoid organs. That's a different word, by the way. And plus our thymus. Our thymus is going to be a butterfly organ. And it's going to sit somewhere right here. And it's going to produce cells called T cells, which are going to beat the mess out of the foreign bodies. And next we have our peripheral lymphoid. I'm going to keep it real. I have no clue what this is. So I'm going to go ahead and look it up real quick. Peripheral lymphoid. Yeah, I'm gonna be honest, y'all. I honestly don't know what this is, bro. All right, moving straight on to it, bro. So we have our peripheral lymphoid organs. What do these do? Google it. And next up, we have our nodules. This is just like our stem cell compartment, except it's gonna be a little tiny. Think of it as an AirPod case. These are gonna be extremely tiny, and it's gonna house our little cells that's gonna need it. And then next up, we got our spleens. If you don't know what a spleen looks like, it looks kind of like a gun almost. And Google it. And then next up, we have circulation. And so once our stem cell compartment, it goes to our central lymphoid organs, which goes to our thymus, to our bone marrow, to our peripheral lymphoid organs, to our nodules, to our nodes, to our spleen, and all that is going to circulate and it's going to repeat back to the stem cell compartment, back to the central lymphoid organs, back to the thymus, to the bone marrow, to the peripheral organs, to our nodules, and to our spleen, and it's going to circulate again. All right, there we go, bro. These are some pretty hard words. Google it, bro. I'm begging you. And so, what did I just say? What's the overview? That's not what I'm going to say. What's the overview? What's all this going to look like, right? What's our immune system overview so far? So first up, we got a foreign challenge. Think of it as, look, this is pink. Pink shouldn't be in here. What's pink doing here? And so pink is going to sit there and colonize. And so next up, we have our natural defense. Hey, pink, what are you doing here? Get out of here, pink. And so, yeah. That's going to go away, right? And then we have specific and non-specific immune response. So when I punched my pink, I could have headbutted it. That would have been specific. I could have punched it. That would have been non-specific. Or I could have even kicked it, bro. That would have been even more specific. And so specific and non-specific. It's kind of self-explanatory. If you need help, then Google it, bro. Your best friend is going to be Google. And so our natural defense factors, we're either gonna karate chop, or we're gonna get a gun. We're gonna get the strap out. And so yeah, and so our body has the natural defense factors, but it's gonna have skin, our mucus, and it's gonna have our cilia. Google it. Gastric juices. That's all your stomach contents. And then we have our lactic acid. Google it. I forgot what lactic acid is. Oh, lactic acid is gonna be on our skin. So when you lick your skin. Oh my God, don't lick your skin, bro. And then it's going to be acid, and it's going to, like, break down the foods. All right, let's keep it going, bro. We're doing phenomenal, bro. Are you Googling? Because if you're not Googling, then I'm going to have to Google for you. And Google. Just Google. All right, so we have non-specific immunity. So say I was just punching randomly, right? This is literally non-specific. I'm just punching randomly, bro. And so that's the same thing what our cells is going to do. But in our body, the non-specific immunity is going to differentiate from itself and from its non-specific self. The camera's kind of crooked. I thought I'd fix it. And so notice how when I was punching, I'm punching literally everything in front of me and not like to me. I'm not like King Kong and his mother. All right. And then we have a non-dependent on specific recognition. Please Google this one. I have no clue what it means. And there's no memory cells. So when I punch something, I remember it. That one hurt, bro. Don't punch the top of your bunk bed. Google it. All right, we're doing phenomenal, bro. But we have different types of non-specific immunity, okay? Now it's going to be endocytosis. What it's going to do is going to take my fist. When it take my hand, it's going to be inside. Endo, it's the Latin word for inside, all right? Inside. Don't forget that. Google it too. It's a pretty hard word. And then we have phagocytosis. And what it's going to do is going to engulf the cell. So I take my fist, I take my hand, engulf. My fist is now inside of my fist, if that makes sense. And then we have pinocytosis. Google it. I forgot it. And then next up we have receptor-mediated endocytosis. So say you had AirPods, right? Your AirPods need to find a signal. They need to find your phone. They can't connect to this hand sanitizer right here because it doesn't have a specific receptor. And so what that's going to do is just receptor-mediated. It's specific. It's specific-mediated endocytosis. Google what endocytosis means. And next up we have inflammation. Say like I bite myself. Ooh, that kind of burns. It's because my white blood cells are going to that site. And they're passing literally through my flesh. It's going to burn my flesh because they're tearing through it. And then that's just going to like get the white blood cells to the site. All right? And then we have natural killer cells. These are natural assassins. They're going to, I got them on Bravo. Blah. Easy peasy, bro. And then toll-like receptors. Google what a toll-like receptor is. I have no clue what it means. It's probably like a receptor-mediated endocytosis. All right, we're doing phenomenal, bro. Are you Googling? Because, like, I'm about to start Googling in a minute. And so we have types of, let's go back. Okay, perfect. So I found out what a toll-like receptor is. It's going to be pattern recognition. So say I go 1, 2, 3, 4, 5, 6, 7, 8. I'm just counting numbers, right? And your brain is going to pick up on the pattern. Hey, if he just finished counting 8, he's going to go to 9. Oh my God, bro. That's fantastic. And so a toll-like receptor is just pattern recognition, bro. Easy. And next up, we have specific immunity. So I punch something, I'm going to punch something specific. You see my dog right here? Instead of punching it, I'm going to punch my UNT sticker. You see that, bro? I found a specific target. So specific immunity is just target immunity, bro. And there are two types. There's going to be active and artificial. And so an actively acquired immunity is going to be from like an infection. No, a vaccination. So when I had during COVID, right? I got a COVID vaccination. This was an artificial type of immunity. And I built up immunity against COVID. Then I got COVID during Christmas break. And Santa still got me presents, but it was no fun not going outside, bro. So artificial immunity. I was oversharing. Sorry if I made you uncomfortable. Artificial immunity, vaccination. A shot. All right. Next up, we got herd immunity. Google this one. Excuse me, I just burped. Google this one because I have like, oh my God, excuse me. I'm just kidding. All right, I just threw up. All right, so herd immunity, Google this one because it's going to be resistance to the spread of a contagious bacteria. So say this was COVID-19, but I got artificially immune to it. And so that just like, it's on me. It's not getting inside my body. It's not going nowhere. But let's say my puppy back here, he didn't get a shot. He's building up natural immunity, right? And so he's gonna be infected. You see that? My puppy is now infected, bro. Because he didn't get his shots. Now, if you're anti-vax, that's too political. I'm not going to talk about it. But that's what herd immunity is. Well, Google it, bro. I explained it like not the greatest. Google what herd immunity is. But next up, we have our primary lymphoid organs. Google it. I don't know what it is. But no, it's going to be our thymus and our bone marrow. So inside of my arm, we got bone right here, right? And that's going to be where my primary lymphoid organs is. It's going to be an immunity system lymphoid organ. Google it, bro. Please Google it. Please Google it. And our thymus is that too. So what's the thymus? It's a gland where T cells get smaller with age. What's a T cell? It just took the first letter of thymus and put cell next to it, bro. So it's just a cell that belongs to the thymus. And it's going to get smaller with age. It deteriorates. It deteriorates. All right, bro, I don't know why I did that. I thought it was going to be like closing a fist. But we got to keep it moving, bro. All right, so the bursa. What's a bursa? It's where B cells mature in birds. Why do we need to know this? Because my professor went over it in lecture. Google what a bursa is and how important it is. But B cells are going to be where the immunoglobulin, Google what an immunoglobulin is. Wait, they're cells with an antibody surface receptor. So, Google it. And T cells, they're going to produce substances that attack infected cells in the body. So say they produce lactic acid, like on your skin, that could probably be an example of a T cell. Look it up, bro. I'm just kidding. Don't look it up. Don't look it up. Don't look it up. I'm explaining it, bro. I'm explaining. You need to Google it because this is just from like a first like responder, bro. And like I'm a college student, bro. So Google it. In a TH0 cell, it's gonna be. I got a text message from my mama. Should I reply to it? Hold up, y'all. No, I'm just kidding. And so we have we have 3 types of T cells, right? And it's going to be our TH0. And it's going to be, what that means, it's an undifferentiated, bro, I can't even say this word. So it's not going to discriminate, bro. It's not going to discriminate against T cells that became either a TH1 cell or a TH2 cell. Now, what's a TH2 cell? What's a TH1 cell? A TH1 cell is an active cell that's related to either cell-mediated immunity, mainly stimulated by a cytotoxic lymphoid sites. Google it, bro. I don't know what these words mean. And a TH2 cell is going to promote humoral immunity by stimulating B cells to produce antibodies. So a TH2 cell is going to become a B cell. Bro, it just crossed the alphabet, bro. Oh, my God, bro. All right, all right. If you need some extra help, keep watching this video, but Google it, bro. Google it. All right, let's keep it going. So we have secondary lymphoid organs. And these are going to be your peripheral lymphoid organs. And that's going to be, all right, keep count. Our lymphoid nodes, our spleen, lymphoid nodules, where T cells and B cells interact with the antigen or foreign material. So did you catch all that? It's going to be lymphoid nodes, spleen, lymphoid nodules, and where T cells and B cells interact with the foreign material. Now, these are all secondary lymphoid organs. rewind the video, because I would rewind the video right here. And so we have lymphoid nodules next, right? And these are going to allow immune cells to be in direct contact with the environment. That's crazy, right? Bro, you could have a lymphoid cell on your skin right now. Let that sink in. No, I'm just kidding. I don't think you can have a lymphoid cell on your body. All right, we're halfway there, bro. Let's keep going. Keep watching the video. We have our germinal. We have a lymphoid tissue, right? This is another name for it. Look at what a lymphoid tissue is, please. Because this Quizlet is saying a germinosensor. What's a germinosensor? And then we have BALT. This is an acronym. It's going to be bronchial associated lymphoid tissue. BALT. Bronchial associated lymphoid tissue. Got it. Now we have MALT, right? MALT. M-A-L-T. It's going to be our mucosal associated lymphoid tissue. Achoo! Mucose associated lymphoid tissue. And then we have GALT. This is second out of the four. It's going to be our gut associated lymphoid tissue. GALT, gut associated lymphoid tissue. Gut associated lymphoid tissue. Yes, bro. No, I added the BERT because, you know, it's a BERT, bro. It's the gut. That's what I think of when it comes to a gut. But next up is our UGALT. It's going to be our urogenital associated lymphoid tissue. Now, urogenital, just think of genitals. Think of a penis, our vagina, our breast. All right. So we have lymphoid nodes. And these are going to be small oval clumps of lymphatic tissue located at group intervals along lymphatic vessels, one of the primary sources where foreign materials encounter lymphocytes. So lymph nodes, remember, go back. The lymph nodes is going to react to the foreign material, okay? Think of it as the living room. Think of it as the porch to your front door. Or you know the inside when you first walk into a door? Let me show you real quick. This area right here is a lymph node. This is my door right here. This is an area if any foreign materials come in, bro. All right, I don't know if y'all can hear me, but where I was standing, if I open the door, that's like the net where all the foreign material is going to be caught. And our lymph nodules are going to send out cells that go to that spot so they can take care of the foreign material. Whew. Next up, we got our spleen. It's an organ, and it's going to filter the blood into white pulp. And it's a primary and follicle and germinal sensor. This is where B cells and perivascular sieves, T cells, bro. Did you know there's global written on the ceiling? All right. So our spleen is going to filter blood. And now it's going to have our B cells and our T cells and red pulp, which is red blood cells. And so our white pulp is going to consist of our B cells and T cells. And the red pulp is going to be our red blood cells. So remember, white, B cells and T cells, red pulp, red blood cells. And next up, we have our antigen characteristics. An antigen is any foreign material. And so each foreign material is going to be non-self. It's going to be foreign. It's going to be alien. It's going to have a high molecular weight. It's going to be complex. And it's going to be digestible. Now, why do we need to know this? Google it. Next up, we have our allergic reaction set. That was rude. You shouldn't Google it. Let me go back. You shouldn't just Google it. You should Google it and come back to this video. And so next up, we have our allergic reaction steps. And so first up, we get exposed to it, right? We get dust. And then we have IgE. That's going to be our cells that respond. That's going to be our first responders to that dust molecule. And we have our mast cells, which is going to build up our sneeze. Then we have our histamines, which is going to trigger the sneeze. And then we got a reaction. And that's an allergic response. Allergic reaction step. Google it and draw a picture. get more reinforcement behind it, come back to this video. Next up, we have our immunoglobulin. It's going to have different groups of proteins. So immunoglobulin, think of it as one big blob of different colored proteins. Perfect. And now we have our these are going to be groups. I don't know how to describe it, but please get some background knowledge. So IgG is going to be blood and tissue and can cross a placenta. Now, why, what's the context behind this, bro? I don't know. Google it. But we have our IgM, and that's going to have blood. We have our IgA, which is going to have secretions and can cross breast milk. So IgA is going to be seeped into our breast milk blood. And IgD is going to be an antigen receptor, so it's going to receive the foreign material. It's going to be that front door, remember that? And it's going to get our cells. Then IgE is going to have our mast cells. It's going to send our sneeze cells, and it's going to prep us for that sneeze. So we breathe in. Oh, hey, we just breathed in dust. Let's go get these clowns. And then it's going to get that reaction. Achoo! Look at what a mast cell is. And then we have aponization, and it's going to have the cell preparing to eat. Look it up. Aponization. I said it wrong. And then we have agglutination, which is cells binding to make eating more efficient. So we're eating. I get another hand. We're eating. And then we have an antibody is going to stop binding. That's going to be viral neutralization. All right? Because if we get too much of that, then we're probably going to get cancer or something like that. And now, a Th1 cell is going to activate a TCTL, and a TCTL is going to bind to an MHC1, and it's going to perform granzymes and kill a cell. That's how a TCLT kills a target cell. Please rewind the next 5 seconds. I would rewind these parts. I would Google it, because that's going to help me, bro. My eyes are starting to act up. And then we have our macrophages and dendritic cells. These are going to be our antigen-presenting cells. Macrophages and dendritic cells. They're going to walk up to our mast cells. They're going to be like, hey, I need you to tell the sneeze cells to go prepare a sneeze reaction, because we got to get this dust out of our nose. All right, I got you, bro. I'm a dendritic cell. I'm a macrophage cell. I got you, bro. And then our MHC1 cell is going to be on all nucleated cell. So bro. Oh my God. Google what an MHC1 cell is. Because I don't know if it's a protein or if it's like an antigen. I'm going to keep it a buck. But yeah, it's going to bind to an endogenous antigen. And it's going to have tumors and viruses, bro. And an MHC2 cell is going to be on antigen-presenting cells. All right? And then we have preference. It's going to create pores. Pores. I got pores on my face. Is that what a paraffin is? Is making these pores, bro? What? And then we have granzymes. These are going to be enzymes that attack proteins of the target cells. All right, that's pretty simple. A granzyme. That's pretty cool. And so we have an antigen-presenting cell goes to our Th0, which goes to our Th2, and that Th2 is going to make B cells, and the B cells make the antibody formation. That's how a Th2 cell presents Ag to a B cell. And so this is going to occur the first time the body encounters a pathogen. This is what's going to be known as a primary antibody response. But we have a secondary immune response. It's going to be how memory cells facilitate a faster and more efficient response. All right, last part. And so we have a lag phase. Antibodies are made by plasma. The plasma's making the antibodies. It's going to take a second. We're lagging behind, but we're making the antibodies for our plasma. Easy peasy. And so next up we have autoimmunity, which is going to be reaction to an immune response to one's own tissues. We did it. That was the last topic, bro. Autoimmunity. You're now autoimmune to a biology test. You made it. You passed. All right, thank you so much. Like